Number 22. If a new graph of three linear equations is created using the system of equations shown and the equation x plus 4y equals negative 16, how many solutions, x and y, will the resulting system of three equations have? When we're talking about systems of equations and we're graphing things, the solutions are going to be where the graphs cross. So if I have two lines, it's going to be that point where they cross. If it is a parabola and a line, be the 2 points where they cross. When we get three equations in that system of equations, it doesn't change. It still has to be a point that is on all three of them. Now, when they're lines, there can only be one possible point. I'm not quite drawing that right. Come on. There we go. There's only one spot where if I draw three lines that all three could intersect, and that's only one. It's not possible. None of these lines are bending, so, I can't have it come back and then, no. Straight lines, it's only going to be that one spot. One is the maximum. So this right here, our little options, we have 0, exactly 1, exactly 2, or infinitely many. 0 is a possibility if I have three lines in this system of equations, because actually I want to draw them in different colors so you can really see this here. So like if I had a line that goes like this, that doesn't go through this other point at all, then that would be 0 solutions. If it goes right through the middle, that would be 1 solution. 2 is not possible. Cannot intersect twice. Lines never intersect twice. Lines will either have, I'm speaking of just 2, but this also applies to 3 lines. If I have these 2 lines, it will either be 1 solution, no solutions, or infinite solutions. Infinite solutions only happens when you have a line and then you have another line that's right on top of it. So it is possible that you could have infinite solutions to a system that had 3 equations in it. But look at what we're starting from. We got this one line going diagonally there, and then we have this other line going straight. It's a little hard to see, honestly, the way they've drawn it. But these are not overlapping lines. So, already the infinitely many is not an option, because that's the only way it could be infinitely many, is if my first 2 lines were drawn right on top of each other, and then this third line that they're giving us that is not currently drawn on there, if it also was overlapping. But that's not happening. We've already got a point of intersection. So the second one here, look at here, exactly 2, impossible. Lines that intersect, whether it's 2 lines, 3 lines, 4 lines, a million lines, the maximum number of solutions, if there is concrete number and it's not infinite, is 1. That's it. 0, 1, or infinite. That's the only options when we're talking about lines, because they don't bend. So now we're just down to 0 and exactly 1. Now, 2 ways that you can do this. Personally, I like sketching things. I'm pretty quick about sketching them. So I would probably just sketch it where it's at and then see if it's going to be heading towards this point, if it's going to intersect there as well. You can also put it into your graphing calculator. Now, there's one little wrinkle with the graphing calculator, which I'll get to in a second. Let's start with doing it manually, as it were. If I have x plus 4y equals negative 16 and I want to graph it, for me, slope-intercept form is going to be the best way to graph this. And actually, there's a second way you can do this mathematically. I'm going to show you both ways. Okay, so first way, if I'm just going to sketch it, I'm like, all right, I'm going to turn this into slope-intercept form. I'm going to get the x's over on the right. So now I have 4y equals negative x minus 16. I'm going to divide everything by 4 to get rid of that 4. And that is going to give me y equals negative x over 4, or negative 1/4 x. Negative 16 divided by 4 is negative 4. All right, so I've got a line that has a y-intercept of negative 4, and the slope is negative 1/4. So I know, even before I draw anything, I know it's not going up here because it has a negative slope. If you're going left to right, like how we read in English, and it's going down, that's negative. Like, oh, he brings me down, man. He's just like, oh, he's such a negative person. I go down. Whereas positive goes up if we're going left to right. So a negative, I know it's heading down this way. There's no way that line is going to come up here and hit that. It would have to be a positive slope. So if I want to draw it in to confirm, a negative 1/4 is rise over run. So I'd go down 1 and I'd go to the right 4. There's my other point. Boom, there's my other point. Oh, it hates when I draw dots. Ah, it just freaks out. It's like a dot. Oh, good Lord, what am I going to do with a dot? Sorry, it just it has such issues with dots. I don't know why. But it's going to be something like that drawn through there. Yeah, it's not intersecting at this point. So that's one way. You can do a quick little sketch of it and you're done that way. Another thing you can do is you can take this point that is the point of intersection that we see, boom, that we see up here that they've already kind of highlighted, and it's right there. And that point is 8, 2. And we can plug those numbers into here and see if it makes a true statement. You don't even have to draw it. See if that works. So if x is 8 and y is 2, 8 plus 4 times 2, or 8 plus 8, does that equal negative 16? No, that equals positive 16. So there's another way of looking at it. Nope, it doesn't work. It will not go in there. If you are graphing this, don't worry about graphing the 2 lines that I have highlighted here, the 2 original lines in the system of equations, because all you really need to know, again, is that one point. That's it. So don't worry about trying to figure out what the equations of these lines are and graph them, because that's going to take you way too long. All you need to do is put that equation into your graphing calculator, and as we showed you, it's going to give you something that looks kind of like that for the line. And then you can either reference back to this and go, hey, it's not hitting that up there. Or you can actually just type into Desmos that point, 8, 2, along with your equation, and it will put your little point up there. And then you can see quite clearly it is not on that line. So yeah, there is no solution to this system of 3 equations. A, 0 is my answer, and there's 3 different ways that you can figure it out. Pick the one that works best for you, that you understand the most, and that is the fastest for you. Hey guys, just a quick heads up, I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe, you know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.